Yeah, I'm Chris Butler, one of the founders and the CEO at OneModel. You know, earlier today we did kind of the innovation section. I covered off some of the pieces that we'll work through here, but you know, what I can do now is kind of go into more detail around some of those elements and how they've come together. So certainly happy as we go if people want to throw out a question. You know, some of it is fairly detailed, so if you've got something that's popping through, throw it out there and I'll repeat it. And we can talk through as we go. But what I'm going to show is kind of a few ways that we've seen customers kind of apply some of the new automated machine learning tool sets to some different problems in HR. And we're going to take a look through that in a few different ways. But you know, we see kind of a progression about how people apply some of this technology and to different problems. You know, over on the left, kind of that, you know, usually they're starting out on, you know, tackling a problem and trying to build, you know, a set of analysis or a model to really go after a set. So there's a lot of, generally a data scientist doing a lot of manual work, you know, manual interpretation and trying to make decisions around what they're building and iteratively trying to improve a process. Often that is, you know, it's very much because it takes so much time, it's kind of siloed and sits on its own. But what, you know, we want to move customers towards is really how do we start to, you know, automate those pieces and take those so that, you know, they then become repeatable. So kind of moving to the building a road. And finally, how do you orchestrate, you know, large amounts of, you know, data science as it moves through and different models and really make what you're doing there part of process. So it's not until you kind of have that repeatability that you can build it into, you know, proper ongoing decision-making processes rather than kind of one-time analysis that, you know, might surface something, but it's the ongoing application and the ongoing review that's going to drive longer-term value from it. So you know, we'll show some of the pieces we have, but I've got some more to go into detail. But to recap, you know, we provide a full people analytics infrastructure for our customers. So we tap directly into systems, bring them all together, make sense of them. You know, we have companies with, you know, hundreds of different data sources that are flowing through us. And we basically have, you know, that core data infrastructure that they need to then sit on top of. So by way of structuring that, you know, delivering an analytics framework, you know, kind of measurements catalogs, getting that data out to the business is easy, but it also sets it up downstream for running the data science activities. So, you know, if you've done any of that sort of work, you know that most of the battle is really getting the data to a point you could use it. And then if you start to extend, you've kind of got to, you know, start from square one again and rethink all of your assumptions about how this data interacts. So, you know, what we did on the right-hand side, you know, we're extending this model, but we needed to build a way to really, at scale, look at any customer and be able to apply, you know, a method to you know, build a predictive model regardless of what the data looked like or how it was behaving overall. So we've taken, you know, virtually general data science methods, you know, libraries and tool sets that are available out there and built an orchestration framework to make all of those pieces repeatable. And the good thing about that is that we can basically open it up and extend it at any point. So if we want to add a new classifier or you know, if we want to add kind of neural networks in there, it's basically the same library that you would use as a data scientist, but we've put a lot of structure and framework around how it comes together. So for people that have some of that knowledge and skill set, you can basically open it up and see exactly what's going on and how to interpret it, and then, you know, lead it in your own directions if you need to. All right, so the overview kind of piece that we had. So this really, we're pulling from that warehouse like we spoke about. The blue box is where everything's happening. So it will basically scan through every data point that we have, you know, and the more data today that we can throw at it, the better. So it's not so much a case of, you know, do we need to selectively choose what we're going to throw at it. Today we basically, as much as we can feed into the machine, the better. So most of the models that are running, you know, over 1,000 features that are at the start of the process, before it will then start to select what makes sense. So it's a huge piece to be able to then create those elements and pipeline them through the process that then become repeatable overall. What we'll show is really, it's great to have that, but at the same time you've got to be able to explain what's coming out of it. So you might have a model that's working really well, but somebody's going to ask you, what's actually feeding into this? How is it getting to those decisions that you've got to be able to back up and show, it's just trust me, it works, okay? It doesn't function like that. If you can't explain, you won't necessarily gain that trust. So transparency and kind of being able to show exactly what's going on, almost to the point where you could take it offline and run it yourself with the same decision points. Imperative, I think, for us to win that confidence of the business users that you're rolling this out to. Okay, so the beating the path, we spoke a bit about the survey pieces, but this is kind of an element where it proves out that you can basically point something like this, an automated framework, at really any data point. So this is looking at engagement score on the example we have in front of us, but we've done different things where we've looked at, obviously filling kind of time to fill, looking at candidate quality, looking at, propensity to move and be promoted, and kind of all of those different things. You can basically, if you can create a data feature around it to show, what the future state is, you can basically point it at that target and allow it to build a model to support. So it's been pretty interesting that, with the framework in place, the problems you can then, bring to bear and start to run through the machine to see if it tells you anything interesting. So that's been, lately customers coming to us and saying, hey, can we tackle this problem? Sure, we'll spin it up and see what it can tell us. So those pieces have been cool, but the output when we put it at something is we're going to get two different pieces. The exploratory data analysis report. So that's going to work through and tell us, what it sees in the data as it works through 1,000 different features. Whether it will select that feature, whether it sees it as important, how it actually adjusted that data to fit through a model. So if it's going to do one-hot encoding or something like that, it will kind of move through that process, and then give us a whole bunch of information about correlations between those data points. The statistical information we showed earlier, and kind of show us exactly what it's doing before it moves through. Now, after that, and we're not alone on kind of the automated machine learning, but it will then go and build 100 different models. Potentially, we've seen it build thousands of different models and permutations of those, and basically cross-test them against each other. So it'll work out what fits that problem that we've selected the best, and come and give us a modelling report of what it found. But I'll show you an example of that shortly. So the EDA, I showed this earlier about what it's doing for each of those questions. This has been kind of massive in a diagnostic sense, to be able to look at the data set, and for the problem that you're seeing, just be able to wade through some of the information that it's generating. It's pulling out the high-level correlations, it's pulling out feature importances. For it to tell us a field is suspicious, or that it's not going to use a field because it's very similar to another one, is huge in being able to determine if there's relationships that we're not seeing, across that data. So we've deployed this quite a lot in, looking at data and using it almost as a starting point to help customers kind of think about, do they want to build around these areas? Are we, trying to surface some, outliers that we're seeing in that data? It's been good to apply overall. But its job is to provide that transparency. Actually, what's the next one? Oh, modeling. Any questions? I've got examples we can show people, but this runs, from here to the wall in terms of the amount of information that it's generating and kind of what's coming out of that. But it will look across everything. Yeah.
Yeah, one question. So it sounds like it might be running through scenarios with different dimensions of things, you know. Is that true? So in other words, let's say I'm trying to see what's happening in these 5 dimensions against these 20 dimensions of things. Is that kind of a process that's going through in modeling and then coming out with some things that are elevated in some of the initial findings? Is that?
Yeah, it will do that as part of that model build process. So after this step, as it goes and builds those models, it employs a bunch of those techniques. So it'll run through, you know, clustering sets, and it will do different k-folds and a whole bunch of pieces to see if there are, you know, some of those relationships might be identified that would be used in the model itself, and then it will kind of come out and tell us what's actually going on. Yeah, does that answer the question?
Yeah, I think so.
Okay.
I would imagine you kind of, once you want to further explore, you go into different more detailed analysis on those as well.
Yeah, exactly. And you know, you can see kind of these other tabs that are out here. There's a whole bunch of information that's sitting behind them about what's going on, and if there are those linkages, or you might be doing you know, combined data points, it starts to surface some of those, so you can see what's going on. You know, most of the customers we deploy don't necessarily have data scientists, so some of it's, you know, they're not getting to that level of detail, but we provide it so that those that do have that capability, have enough to be able to see what's going on. All right, so you know, after that runs, it's then generating all those models. We need to see, you know, what it's actually deciding at the end of the day, and virtually we're giving every parameter that you might have built into your own program. Yes?
Now, when you're running these models, are you basically, and you say you've got like 1,000 features there, but you're basically saying, I really want to run it and looking at one thing, retention rates or something like that. Is that basically what's happening?
Yeah.
So I've asked a question that here's what I want to look at as the result.
Yeah, so we've given it a target, which might be the problem that we're looking at, if that's turnover or retention. We've given that on the front end that I want to be predictive about this element. Okay. And then where the 1,000 different features that we might feed it might be coming from, you know, 20 or 30 different systems, and you know, we basically all connected them together by that point as it is. We're going to feed it through, and it's going to decide what's important. So it might go from 1,000 features down to 60 that it finds as relevant.
Now, have you had to scale or normalize all 1,000 of those features as a pre-step before going in to the model?
So by virtue of the fact that we've already modeled that data in the warehouse, so because we've delivered that infrastructure in the first step, so we're already doing analytics and reporting and those sorts of things, and on, you know, through the presentation as it is, it's already modeled and knows context of each other already. So it's kind of already clean and ready to go, which is half the battle in kind of getting to that point, and enables, you know, these sorts of tools to sit on top very rapidly.
Okay.
Good questions. Yeah, so I mean, it's going to run through that and give us some information about what's coming out, and this is all about deciding whether or not that model's accurate. Can we use it? Can we deploy it? You know, so as we move to an ability to run these more regularly, you know, we need to decide whether that's a model we want to persist and kind of move forward with, and run those elements out. So enough information has to come through that we can see what's going on, and you know, explain that to people if they question us. Including obviously performance. How well did this perform? You know, at this point, it's going to be the highest one that's coming out about what it's doing. All right. So how we'd get to the next step around those problem sets. So, you know, we've done an initial analysis. We've kind of seen what's coming out. And if I was doing this manually, it might take me a few days, a week to kind of get to an initial point that I'm happy with there. You know, we've allowed a machine to kind of do that very, very quickly and run through that data set and give us a lot of that information. The next step that we see is that we need these pieces to run regularly. So we want them to go back and look at all of that data again, to remake all of those decisions, whether that's on a monthly basis or a weekly basis. If, as those patterns and behaviors change, it will make different decisions next time. So this is how do you get to that next step where you're trusting that the model's working, but we need to make sure that we're updating data and that we're our model is not decaying too badly, right? So all models will decay over time. How do we make sure that they're up to date and that they're functioning properly? So schedule those pieces through, and you can see kind of, if anyone's interested, all of the runs are basically captured to give you the information of everyone that's run through. What's been pretty interesting lately is we've added to the product recently the ability to meta-learn from itself. So it will capture every single model that it builds. So even each one of these runs, it might build 300 different models. It will capture every one of those and track them over time to see if something else performed better than what it actually selected, which is pretty cool, because when you feed that back in, it starts to make different decisions. So if I point it at turnover, it's going to learn from, I selected these features last time, it kind of performed this way, but the model that was third in line actually did better. It will start to change how it makes some of those decisions to become more accurate. And that's been unbelievable. We jumped about 10 percentage points in accuracy pretty quickly by looking at the back catalogue. So that stuff's been really cool. All right, so getting to that highway step, and happy to go into some more detail because this is a pretty cool use case for people that are interested, but that being able to kind of tackle different problems, and what we did here was around workforce planning, so that steady state company that people heard about us before. That was a need that they couldn't tackle manually themselves. They just didn't have the resources to get there. So setting up multiple different models, a number of them kind of feeding into each other to help drive an outcome that they couldn't manually do by hand. So there were, of the models that we needed to create here, we obviously had to target attrition to find out how many people were going to leave overall. But as part of, you could almost think of that as somewhat of a straight regression type problem. But feeding into that, we did a employee level risk analysis. So each person had, their risk of turnover being fed in as a feature as well that was taken into account with kind of the overall risk profile. So, if we saw increases in people's risk, those pieces would be weighted to be able to come out with, this is the expected turnover that we're looking to see. On the recruiting end, time to fill, basically. Sorry, question?
So I had a question about the models. So you would have all your features from internal data, but are you also able to include external factors like the economic, or the market? Are you able to include those kind of features into predicting turnover?
Yeah, absolutely. So anything that we can feed into it and join into that data model set, we can push into these models as well. So you might have, local unemployment rates around where somebody's living on their zip code or something like that. That could all be fed in as a feature as well. So it would take that into consideration. We've got some data sets that we generally bring to bear to enhance, what a customer has. But if they also have their own, all of those pieces can come in. So often we see, their own industry benchmarks and those sorts of pieces I'll introduce in that. So yeah, absolutely. The more context, basically because it's, we don't have to worry about how much data is feeding through. The machine's going to select what it wants to select. The more we throw at it, the better. So we're kind of getting to the point that, it's the more context we can give the machine about a subject area, the better to feed it through. Does that make sense?
Yeah.
All right, cool. So and on the back end with sorry, not on the front end around recruiting. Obviously, the problem was of the requisitions we have open, because we want to stay steady, how many of them are going to close over the next period. If we open others for different positions, how long are each of those going to take to fill? And we've got our target timeline in front of us. So generally we're looking a month, 2 and 3 months out to be able to see where that's going to fall. And when you pull those pieces together, ultimately the question that they had to put through is, of the positions that the organisation is asking for, how many of them can we actually approve and open those requisitions up? And so that's, would normally be pretty intensive tasks. Yep, question?
Can you somehow label, like if you have an intervention that you're trying to improve on something, can you label in some way through the metadata or whatever that this was what we were seeing before the intervention, this is what we're seeing after the intervention in some way?
Yeah, absolutely. And particularly for things like turnover, where if you then go and put an intervention in place, even a simple conversation, the advice is that you have to track all of those and feed them back in so it can learn from what's going on. As soon as you take an action, basically the model's almost, I wouldn't say destroyed, but it's no longer reliable for that person. So yeah, our customers that have done it, we've got them to kind of track all of these actions as they do so. For the most part, that's pretty, not sophisticated. It's them filling out a spreadsheet about what they did, and we're feeding that in as a data point. So yeah, that definitely has to be introduced. So that's one of the complexities, that as you start to roll some of these pieces out, how do you make sure that you're capturing some of those actions and that they can be fed back in so that they're taken into consideration? Cool. Yeah, and we showed this before, but basically the scale then becomes quite enormous. So we were talking about 5 models for each department or region, and that could be amplified depending on how granular you want to get. So you might have, because there's differences in business units or even between countries, they might come out with different models as they are. You could run kind of one large model and allow it to make its decisions around those different regions. But we found, we kind of do that as well as doing individual pieces to see how well they perform against each other. So huge amount of scale, but that's kind of been the good thing about automating this process. It doesn't matter how big it gets then. We just spin up a few more machines to be able to crunch through in that sort of time frame. Yeah, so we kind of had a few questions like this, but it was funny, we looked up a definition around what's a machine learning engineer, and it basically explained a lot of what the tool set was doing. So it's essentially an automated machine learning engineer. That's kind of the AI part of it. The intelligence is automating decisions is normally how you classify AI. How do you automate some of those decision pieces? And it's really about how do you automate the data science decisions on the front end to get to that. Not that it's replacing people. The idea and how I've seen it deployed is it really becomes a productivity tool for people as they're building their own predictive models, as they're kind of getting it out. How can they work faster? Have something kind of take care of all the decision making process around features, and then use their own insight to check and kind of validate that these things are okay. And kind of that's some of the key points. And if you kind of see what we use, we open up to be able to allow a user to force your own decisions through the machine as well. So if you feel like this feature should be considered, and it's dropped it for whatever reason it's given you, you can force it to look at those pieces. You can force it to weight different classifiers in different ways, and kind of do all the stuff that you might do externally in your own Python or R style of programs, still provide that same level of flexibility. So it's been key to make sure that we're not your skill set is being used at the greatest level of scale possible, and that you're not wasting time on things that should almost be mundane, right? Yeah. Any questions out there? Happy to talk about other scenarios as well.
Yeah, can you talk a little bit about your process in terms of bringing new clients online, in terms of how your team helps walk through the data connections, reviewing the results, and kind of maybe a little bit around the timelines?
Yeah. So normally when a customer comes on board, we've got a wish list of all the data sets they want to go after. We'll tackle the big ones first. So straight into the HRIS is generally the first cab. And then any of their priorities to come downstream. So if it's a Workday or a SuccessFactors, Oracle that has an API, we'll go straight into the API and start sucking everything that we have availability to out. We then will drop our data models on top. So back on that, the data modeling pieces. So for each of those systems, we've generally got a template that we would apply. And then we customize for the nuances that each customer has. So if you've done a lot of custom object building, they will be updated to reflect those pieces. And then each system kind of, travels down the same pathway. We've been, so for an HRIS system, generally we'll have a customer, depending on the size of the system, it might take us a week to get the data out, just because of how slow some systems are versus others. Workday's kind of real slow. That time to get the data out, then the modeling, it might be 2 or 3 weeks before you're actually in there reviewing your data and validating and working through that process. So we've got a bunch of validation and data quality tools that our customers use to make sure that what we're counting is what they were expecting, and if there's any logic changes, they get adjusted on the fly. So it's a pretty fast process to get to that minimum data set you can start using. But once it's in there, it's interconnected. So each of those models have a context of each other, which lets you do cross-system reporting and analysis pretty easily. But that's really what's setting it up to be able to run the data science downstream quite quickly. It takes care of a lot of those data challenges once you move through that process. And as again, that's all designed to be automated. It virtually never needs to be touched once you're in that process. So, do you want to redirect or follow up? Okay. Anyone else?
Are you doing this in the cloud?
Yes, we are hosted completely on AWS.
Okay, do people have concerns about putting proprietary data up in the cloud?
So you used to see, 10 years ago there were more concerns. It's not so much anymore. There's still a few old school companies that won't do it, but virtually, half of businesses have kind of moved their HRIS systems to the cloud now, so they're already there. It's really a case of when we're working through a process, that's obviously a big piece of what that needs to be. But if you can show all of the security layers that you've got in place, and InfoSec teams will go through everything with a fine-tooth comb, you tick all those boxes, and they should be happy enough to put that data out.
Yeah,
So that's not.
Yeah, I think as you were saying, that was a thing in the past, and I think people are becoming more comfortable with it now.
Yeah.
Okay.
There's probably only one organization I've seen over the last 3 years that, said, "Oh, we can't do cloud," and they're a huge bank, but we just brought another US bank on that, has allowed us to go through into the cloud as well. So.
Is there some sort of metadata layer that you could extract more governance stuff from? So I'm thinking, the data definitions, the lineage, all that, because that's one of the very time-consuming things that we run into right now. Is it's kind of independent. So I'm just kind of curious if that's something that can be extracted through your product some way?
Yeah, we're actually quite transparent about all of those pieces. So you can open up the individual metrics, just how they're calculated. As the models process, you can look at each of those models and see the lineage of steps back through from how we got to that. So, you know, when we look at a system like Workday, we end up pulling 800 or 900 different tables out. You know, we're coalescing that down into a set of analytics-ready data models. So you can kind of see that lineage through. And if you click on, we're not showing any of those, but in the dashboards and the visualization set, click on any of those metrics and it pops up. This is the calculation, these are the tables it's coming from, and any other relevant information, and right down to the individuals that are in those numbers. So yeah, that transparency and kind of showing people what we do. We even, you know, the processing layer, you could even drop out as, you know, a massive SQL file that you could go and run somewhere else if you want to. Yeah, we're not adverse to sharing exactly what we do.
Is there anything in that could also provide a business definition of something?
So our metrics catalog contains logic and kind of descriptive elements around this is what this metric is, what it does, how it's calculated, is all contained within the catalog itself. Is that what you're asking, or something else?
Yeah, something like that. So, you know, if somebody like clicked on something, let's say we used a dashboard that you had and it has a, I don't know, mouse over or whatever that says something. If we wanted to say, you know, this is what you're looking at, is from a business perspective. So let's say it's something on voluntary turnover. So what does that mean, right? So this is what it means.
Yes.
From a business definition perspective. So I'm just wondering if that piece is somewhere in there.
Yes, exactly. So if you clicked on that number in the front end, it will pop up a window that says this metric. You know, it could be turnover rate or something like that. You know, turnover rate and whatever description that we've applied. We generally have a set of standard descriptions, but you could alter it and make it your own. So it might be, you know, noting that you know, turnover for interns or something is excluded from these metrics, and kind of be clear about how some of those pieces come together. So the governance in terms of, you know, communicating what this is basically available straight away. So you just click on it and it opens it up.